Welcome back. It's time to get the mirror fixed in the middle of the carousel so you can see it from the front. 45 degrees, wonderful, and it's made from mirrored acrylic so I can laser cut it. How exciting. What an idiot. Another day, and I want to start putting together the enclosure that holds the Arduino and all the works and bits and pieces for the Climatic Revelator. And I've been fiddling around looking at these bits of wood, trying to remember how to fit them together, trying to find photos on the computer of how to fit them together and the little angle bits. And eventually, after wasting about half an hour unsuccessfully, I thought, I wonder if I've got any instructions or notes written. Look. What an idiot. Details, dimensions, sizes, how to fix them together, where to sand them. Fantastic. I can't tell you how pleased I am. I'm so thrilled that I did that, took the trouble to do that. And there we are. I've cut these pieces of wood and then I can arrange them all nicely and know exactly which ones go where. I believe that one goes there. Isn't that a joy? Well, I get on and get all those glued together. Fits together perfectly, interlocking corners and everything. Now I haven't glued that bit because before I glue that I was just going to mention these again. I've mentioned them in the past. They are brilliant. They are rivets for jeans or fabric, items of clothing, fashion, something I can't remember. Anywho, they're perfect for this because they're sort of antique brass colour. Get them in different sizes, and this particular size fits in this particular hole. It's one of those lovely things to glue in. So it's most enjoyable. Great thing about that is it's going to line up with the inputs, the USB socket on the Arduino that's inside. And the great thing is that this stripped down USB type B or whatever plug actually fits through the hole, which is fantastic. Because it means it stops people poking things in and whatever. But if I need to reprogram it, put a new sketch on it, I can just plug that in and it fits. Thank you. Just working from some more lovely plans. This is for some variable connecting strip with two reed switches on to sense the position of the carousel. Here's a bag with a magnet in it. I've also connected my multimeter up with the lovely new clip things that I got recently. Right, magnet in there, let's see. Yeah, brilliant. And I've checked the other one, so that's great. I'm doing all this while I'm waiting for that to dry so that I can then fix that down onto the base. And in the background you can probably hear the laser cutter, the dear blessed laser cutter. I've given it the job of cutting out all the 10mm parts. Because it goes at, is it 1.5mm a second or something on 40% power to cut 10mm thick acrylic, it does take quite a while, so it's nice to have things to be getting on with. Beautiful though it is, sparklies, how lovely. I've just noticed that, heavily underlined, check first 5mm deep slot. Can't remember what it means, but I've lined this up and stuck it in place with blue tack. And I'm going to get this, the carousel with its magnets underneath, sitting there. Right, intermittent to say the least. And I couldn't get the other one, the data one, to work at all. Okay, I've got that screwed down in the right place. Completely forgotten about trying to get the reed switches aligned and things, and I've started working on this. This is the LED module that produces the light to illuminate all the little silhouette scenes. It's a 3 watt warm white. Cold white's horrible, warm white lovely, good. They're called keys for some reason, keys LED modules, and there's a little transistor on there as well, and a resistor, so that you can connect the signal input of this directly to an output of an Arduino, a pulse width modulated output, so you can fade it up and down and control brightness. How fabulous! And to ensure, because obviously this is quite a small box area for 3 watts of very hot LED, obviously I've allowed lots of room for the heatsink for air to travel around, but also I run it at a very, very low power, initially set by the output from the Arduino. I just didn't need to be so bright, so I think it's working at sort of like 10th power, so that's good. And to ensure, even if the Arduino decides to go wrong and feed full output to this, to ensure it can't overheat, 3 things, I believe. There are 3 diodes wired in series, which basically absolutely ensure that even if this is switched full on, it can only receive however many volts less than 5 volts, that is 4.5, 3.5, something like that. I've tried it and tested it and know that that will actually limit the current to the LED, so it can't overheat with that. There's also a fuse, which also adds a little bit more resistance, to ensure that if everything else somehow goes horribly wrong, this will then blow because it's not going to allow you to exceed the current. And the third thing I think was actually just the fact that the Arduino is running at a low pulse width modulated output. And that's really solid, lovely 10mm acrylic. Right, I'm going to get that screwed on. I must get back to the reed switches. Hole filled in, sounded smooth. This won't be seen, doesn't matter. Now it goes round. I'm just checking the datum one. Yes, that's what we want. I'll check the other one. That's great. My brain is a muscle. I need to line this up. 55mm as it shows on the drawing. In fact, 55mm. And I've looked at this and I thought, oh, wouldn't it be nice to have a card jig spacer? Thinking, yeah, I remember making one. You can see where this is going. Got the cutting mat, got the cardboard, starting to make one. Oh look, paper clipped onto it. I thought I would have lost it because I'm an idiot, but I actually had the sense to clip it on. That's great, lovely. Just going to cut out the 3mm sheet, and the lovely thing about it is you can have different colours and set them on different speeds, different powers and all the rest of it. So I'm just cutting out the 5 little rebates that are going to hold 5 red felt discs, so that each time the chime mechanism works and the thing thumps back down, it doesn't thump, it settles nicely. Good morning. I can't remember where I am after that little tap stroke faucet interlude, but it's not dripping still, which is lovely. Look, that's down, this is spinning, reed switches are working, Arduino and interface for the motor fixed there, and the amazing, I've talked about it before, but it is thoroughly incredible, barometric pressure sensor. It uses the 2-wire SCL SDA I2C, that's it, communicating system that's supported by the Arduino. So you just have 4 wires from it, positive, ground, and the SCL and the SDA, the clock and the data. And that's it, that's all you need to connect it to the Arduino. And then this incredible device that uses apparently a Bosch pressure sensor, which is that titchy little thing there with a hole in it, to read the barometric pressure to an accuracy of 2 decimal places. That's 2 decimal places. Isn't that incredible? Anyway, time for switches. Here's a switch, here's a lump of plastic that it fits in. Luckily I had notes. Here's the outside instruction, I can never say that right, twiddly bit to go on the outside. The switch is going to go there with a lever on it, and then I can fix the motor on there. It's coming together nicely, as they say in the trade. Why use 2 drive shafts when you only need 1? Here's the first idea, which was very complicated and had 2 parts to it and all sorts of stuff. Wrong, check. Then on to an even more complicated one with a smaller bearing and 2 separate parts that fitted together. Finally, I managed to invest in this beautiful bearing, which has got a 12mm awl in the middle. Isn't that fabulous? Which means the whole shaft could be turned in one piece out of a 12mm brass rod. Hole in one end with 2 grub screws to fix onto the little motor shaft, and even, which was a problem when it stuck out too far, it didn't look right, so I rebaited it a bit, and there's just room for a lovely gem on the end. Thank you. Right, let's get that turned down, or up, or sideways, or something. Luckily, I've just got this piece of 12mm brass rod left. No pressure there then if it goes horribly wrong. Now the thing is, that's 12mm diameter and this is 12mm diameter, so they're not going to fit together because you need a little bit of a gap. So I'm going to turn the outside of this down to 11.9mm, should do it. Methyl blue and all sorts of clever geometric shapes to mark it out. Nah, a Sharpie and a ruler. What a mess. But ever the useful V-block again. Now I can rest it on here while I drill the hole for the 2 grub screws. And then, as always, in the present modern day whatever, we're going to use the lovely drill tap. But look at that, once you've got a pilot hole drilled, it's an absolute joy. It really is. It's one of those tools that, just like my deburring tool, it brings a spring to my step and a smile to my face. It's fabulous. What a great little thing. And it also means that, you know, you can cut out holes with the laser cutter that need tapping, and even though they're slightly conical, as long as they're smaller than this will tap them absolutely perfectly, because they'll guide it through, so you don't have to worry about it being on the wonk. Brilliant. Right, almost finished. Let's just pretty up the holes and things with the countersink. No one's going to see it at all actually, but I know it's there. Look at that, 8mm drill, just touch the tops and it just makes a beautiful little edge. And it always reminds me how much I love engineering drawing. I remember falling in love with it when I was at school doing TD, technical drawing, that's right, at secondary school. And we all had a drawing board with didn't even have a parallel motion actually, we had to have a big T-square. Remember all the morons in the class, the bullies and stuff, one day they all used their T-squares upside down with that angled back. Absolute. Anyway, I used to love that lesson, and then obviously going on to do industrial design and engineering, learning more about it and everything, but it stays with you, all the conventions, and it is such a beautiful system to use where you stick with all the same conventions, and then theoretically an engineer anywhere in the world will be able to look at a drawing and immediately understand it, and more importantly I will look at a drawing I've done and understand it. Lovely. And while I've been doing that, I've done all the engravings, which is lovely. I've got the engraving for the meter, because that's another job, to adapt the meter into this reading, the hectopascals. Lovely. And the engraving for the number and other bits and pieces. Top of the switch, that's why I did it. And it's a joy, isn't it? It just cuts them out so beautifully. I've just redesigned this one. Look at that, it's got my website address, so small because it's been raster engraved. It's absolutely perfect. Oh, calm down, calm down. Let's broach the awkward subject of ball chain. Fabulous stuff, because it will transmit motion but through a variety of different angles, which is great. Normal chain, like bicycle chain, obviously only works in one plane. But for example, here's the top of the epizooscope, and you can see the ball chain goes round there, changes direction there, but then it can also go around that way. And equally with the Climatic Revelator. Fabulous stuff, ball chain. Then I ran out of it. I thought, okay, 3mm ball chain, buy a load more. And then I checked, thankfully, and found it wasn't exactly the same gap, or pitch I suppose you'd call it, as the original. How frustrating. So I remember spending hours, if not minutes, trying to work out the original pitch to make these pulleys for the ball chain. Sounds simple, measure the centres, etc, etc, but it turned out to be really complicated as you bend it and things and the chain sort of shortens. So I expected to spend a long time doing it, but I didn't. To cut a long story short, I cut out a couple of these with the inner radius, wrapped the chain round, counted the number of things, and thankfully they came out at exactly 30 balls for that one, the smaller pulley, and 39 for this. It was absolutely perfect, a joy. So I drew them up and made the changes and cut some out to test them, which worked. So I've now just cut out the new one from 5mm acrylic. Let's see whether it works. It fits. Look at that. So I remember the first time, stop Richard Light. I remember the first time I kept thinking it was right and adjusting it a titchy bit, but you'd find that you'd jump a ball, so to speak. But that's absolutely fine with the radius. One lunch later and some glue setting, and we have it. Isn't that lovely? Only thing is, I'm going to have to spray the brass with brass paint, but never mind. It was because it's the best way to put this together to get it to all line up, and I was glued in there with my old trick of 3 very small holes, semicircles, that you just drip a drop of super glue in, and it soaks in and sticks it like the proverbial shovel. Right, stop talking and we'll get that sprayed up. Now, whilst the paint's drying, I think I'm going to try and put the PIR sensor together. This is a tap, 1/2-inch tap connector, so that one I can screw into the enclosure, and this one normally is a compression fitting that clamps down on 15mm pipe. But, to friends, this is the type I usually use, and they're about £3.50, £4, £5, something like this. However, there wasn't room on the Climatic Revelator for one that big. I discovered these amazing things. These are made by Philips. Absolutely incredible. They're completely self-contained PIR sensors with 3 connections. So just plus 5 volts, 0 volts, and the output that goes directly into the Arduino. They're amazing. No adjustment or anything. Really, really good. And the even greater thing is, because I was trying to work out how to fix them in a plumbing fitting, again, these rivets, fabric rivets for jeans and such like, the smaller one actually just pushes on there, and then I glue that, fingers and thumbs, into a larger rivet, like so, with araldite, and then that, I glue into the nut on the end, so it's all centred up, and that looks really nice. Isn't that incredible? You can fit all that inside. The wires only just protrude, so there's plenty of room inside here, and it means that different inventions and things. You could add a PIR sensor anywhere that you're using sort of 15mm pipe. Fabulous. Right, I'll get that soldered and glued in place. This is what I love about steampunk inventions. A rotary switch. You could have a boring rotary knob on it or something. Alternatively, you could have a beautiful control like that, and a felt washer. So the felt washer pushes on there, and you've got that lovely brass red sort of thing going on, and then a lovely knob with a pointer and a little polished wooden knob on the end. Now, I'm not going to do this single-handedly, but that will then move over a curved legend on the top. What fun! Oh, and here's the glued-in PIR sensor. Isn't that amazing? In the end, I did have an extra resistor, a pull-down resistor, 68k. Luckily, I had a series of lovely little drawings with a little bit of Veraboard, 3x3 holes, and there was a 68k resistor. Well, it just fits there, and I'd even got a circuit diagram. There we are, fixed on. Look at that, gorgeous. And then the legend for that is this. So it can indicate the pressure tendency on the gauge just by increasing, decreasing, or it can display the current actual barometric pressure reading, or it can display the last 24 hours of pressure readings, and then play all the tunes and things. And that needs to be curved, hence this 10mm bit of acrylic. So that's going to fit on the front panel, like so, and then somehow, with the aid of a hot air gun I think I did last time, that's going to bend round there. I've got the pulley on now, and obviously the switch done. I've also, this is now painted, so I'm about to assemble the tensioner, which is fun. And while that's been setting and drying and stuff, I've made the thing that supports the chime hammer, the thing that sits in the middle to stop them from swinging around crashing into each other. So that's nice, it'll be an ornate. And a thing that holds one of the ball chain pulleys as well. I'm going to cut. I've tapped it, as you can see, drilled it, tapped it. Now I'm going to paint these bits up. The fun never ends.